So far, we've looked at solving a linear system by graphing, which is okay, but can be challenging if the point is not nice or if the numbers are very large. An algebraic way of solving a system is by substitution. And so in order to solve by substitution, your first step is to isolate one variable from one of the equations, usually y. Second step is to substitute the expression from step 1 into the other equation. 3 is to solve for the unknown variable. 4, substitute back to solve for the other variable. 5, state the point of intersection. And then 6, double check your work. Let's do an example to see those steps. So the first thing that we're going to do is rearrange one of the equations to get y by itself. So I'm going to choose this one to rearrange because there's no coefficient for y, so it should be pretty easy. So I would get minus y equals minus 5x plus 2, and then I would get rid of that minus sign, y equals 5x minus 2, and now I've got a new equation, 3. So now what I'm going to do is substitute that third relationship I created into equation number 2. That is why it's called substitution. So let's highlight this in pink, and I'm going to replace that right here where the y is. So 6x plus 3. Now I'm making my replacement. Y equals 5x. Well, I guess I don't need the y equals. That's what I'm replacing. So 5x minus 2 equals 36. So now I have a relationship that's only in terms of x, and I know how to solve an equation that has one variable in it. So we'll expand. Double check that I did that correctly. 3 times 5x is 15x. 3 times minus 2 is minus 6. I'm going to keep going, so I get 21x equals 36 plus 2, 6 is 42. Dividing both sides by 21 is going to give me x equals 2. So now I've solved for one variable, and now I need to solve for my other variable. So I'm going to substitute x equals 2 into my relationship here that I created for y. So I'll use green to demonstrate that. So I'm going to take this and I'm going to substitute it in right back in here. So y equals 5 times 2 minus 2. And now I can evaluate that for y. 10 minus 2 is 8. So that means that my point of intersection is 2, 8. Much easier than graphing. Now I substituted in y equals 8, or x equals 2, back into my first relationship, really, the 5x minus y equals 2. So I can always double check by substituting into my second equation. So I'm just going to do that verbally. You only have to check verbally, really, or in your head, unless you're asked to do a formal check. So let's see. If I look back up here, I would have 6 times 2, that's 12, plus 3 times 8, which is 24. 12 plus 24 equals 36. So I know that my answer is correct. So let's do a second example. My first equation here is 5x plus 3y plus 5 equals 0. My second equation is x plus 2y plus 8 equals 0. Now I'm asked to use substitution. I know I need to rearrange one of the equations to get a variable by itself. This time, I see that my x doesn't have a coefficient or has a coefficient of 1. So I think I'm going to rearrange that one this time. X equals minus 2y minus 8. Okay, now I'm going to follow the same process I did before. I'm going to sub my relationship that I created back into my other original equation. Try and use the same colors here. This is what I'm substituting right in for x in my first equation. So here we go. We've got 5 times minus 2y minus 8 plus 3y plus 5 equals 0. I can expand and simplify in order to get my equation. So minus 10 plus 3 gives me minus 7y. And then I've got minus 40 plus 5, so minus 35 on the left side. I'm going to move that over to give me positive 35. And this is going to leave me with minus 5 as my value for y. So now what I'm going to do is I'm going to take that value for y and I'm going to substitute back into that relationship that I created. So here we go. So sub y equals minus 5 into my x equation. And I've got x equals minus 2 times minus 5 minus 8. And then I can simplify that. So 10 minus 8 is 2. So that means that my point of intersection is 2 minus 5. I'll double check that in my first equation up here, the one that I didn't simplify. 5 times 2 is 10, plus 3 times minus 5. So that would give me 10 minus 15 is minus 5, plus 5 equals 0. So I know that that answer is correct. We're going to do one more example, and here we'll do a formal solution. So you can also have a's and b's. Doesn't matter what the two variables are. Again, my first step is I'm going to rearrange one of the equations so that it has one of the variables by itself. I'm going to choose the first equation because I see that the a has a coefficient of 1. So I get a equals minus 5b minus 7. It's my third relationship I've created. And I'm going to substitute my third relationship into my second. So my third relationship here is going right into where the a is in the second spot. So I've got 3 times minus 5b minus the wonky 7 minus 7 minus 7b minus 1 equals 0. Minus 15b minus 21 minus 7b minus 1 equals 0. Now I can collect like terms. So it looks like I've got minus 22b on the left side, minus 22b on the minus 22 on the left side turns into positive 22, which gives me b equals 1. Minus 1, excuse me. So now I'm going to substitute my answer for b into the equation that I created for a. So my b, I'm going to substitute right into this equation to solve for a. A equals minus 5 times b, which we have as minus 1, minus 7. So I'm going to get that a equals plus 5 minus 7, which is minus 2. So that means that I think my point of intersection is minus 2 minus 1. So let's check formally. So that means that if you remember from our previous video, we need to check the left side and the right side of both our original equations. So let's do equation 1 first. Our left side is a plus 5b, and our right hand side is minus 7. So we'll put in minus 2 for a, minus 1 for b, and we get minus 7. Great. And then we'll check our second equation. So left side and right side. Our equation 2 is 3a minus 7b. Oh, and we have everything on the left side there. So 3a minus 7b minus 1. Our right hand side is 0. So we're going to put in minus 2 for a, minus 1 for b, and then minus 1, and we should get 0. Minus 6 plus 7 minus 1, bingo, 0. And then we can say, since minus 2 minus 1 satisfies both equations, it is the solution to the system. Here is an alternative algebraic method to solve a linear system.